Hello everyone, welcome to Learn Overflow. In this video, we'll discuss about today's LeetCode problem. There is a number of matching substring. Okay, so this is a medium level problem, and we'll understand what this question is asking us to do and how we should think on solving a question like this, and what can be the multiple solutions or multiple thought processes behind solving this particular question. So we'll look into one by one into all of this, and ultimately we'll find an optimal solution, a good solution rather for this particular solution. We write a code for that and ultimately run this code. So that will be the whole video all about. Also, if you haven't subscribed to this channel already, make sure to subscribe to our channel for regular lead code videos like this. So let's start today's understanding today's question, and let's see what this question is asking us to do. So at first place we're given a string s. So this string s is simply a string s given to us, okay, and an array of string words. So there's an array of strings called words. So that's given to us. There are two things, and we need to return the number of words I. So we need to return a count of this words I. That is a subsequence of s. Okay, so number of words I, that is subsequence of s. So there's a small thing when it says subsequence and when it says substring. So there's a difference. Okay, so say if there is a string something like this, like written over here, fine. Say there's a string over here, and when it says subsequence, subsequence can be, it can be like this string, this character, and the last character. Fine. So that's a subsequence. But when it says substring, that means it should be a continuous flow of strings. So like continuous, really, one after another should be there. So that's a substring. But when it says subsequence, you should make sure that it can be each character can be anywhere from the string. So you can pick it from in a jumble order as well. So that's subsequence, and the other one is substring. So that's the small difference you should remember. So let's understand further. So here they have also explained what is the subsequences. So it says like a subsequence of a string is a new string generated from the original string with some characters. Can be none as well. So can be none characters as well. Also, like delete is with some character deleted without changing the relative order of the remaining string. Okay, so they mentioned that it should be like the order shouldn't be changed over here. Okay, so that will be our idea. So it says like ACE is a word. In that case, what will happen? ACE is a word, and if a subsequence like ACE is a subsequence of this A, B, C, D, E. So A and C and E. So all these are in the relative order, in the same relative order, and thus we see that this is how we are finding a subsequence. Awesome. So let's understand an example and see what the question exactly saying us to do. The question is like it's a like string s is abcde. That's a string s given to us, and there's a words array. Words array contains five words, four words rather. One is a, bb, acd, and ace. So this four words are given to us, fine. So and it says the output should be three. And why is it so? Output is three because like there are three strings only. Like in the words array, there are only three strings that are a subsequence of s. How a is a subsequence? We can find that a is there in s. Then a, c, d. We can find a, c, and d are there in s without like changing the relative order, fine. And then ACE, you can find A, C, and E is also there without changing the relative order. So there are like three words in our words array, which are a subsequence of this. Fine. So that's the question we have now. We can easily understand what is this all about. Now, after reading this, the first type of solution or the first type of approach that comes to our mind is like, wow, we need to go through this. So let's do something like take each of the words and do character by character, check for the each character and find if if any character matches with this, like there's a b, c, d, and then e. Fine. So these are the five characters we have in S, and we first take A, like for the words array A. We find that A is equals to A, so we increment our count as one. Fine. Then if I in B, so we start from the zero and travel to the next one. We find a B over here. Okay. Then we like it's more like we got to B as our word. Okay. So if we find the first character and we find a match to a first character over here, then we increment our this counter to the next character. So we find another B, and now we keep checking for the next characters till the end. There, what is another B? If we don't find another B, we break and like we go to the next one. So this can be an approach. Fine. Then we find words like A, C, and E. Again, we start from the beginning. Fine, we find a match. Then we increment its pointer to the next character. Increment its pointer to the next character. We don't find a match. If we don't find a match, we increment it further. We find a match. Okay. Once we find a match, we increment both the character, like both the pointers. Then we find it's not a match. Then we increment it further. Then we find a match, and we come out of the particular loop. Okay, and increment our counter. That okay, found two matches. So this can be an approach, but this may not be the best approach you can come up with. Fine. You need to think that what can be the other approaches that you can think of, because if you go ahead, like there are like, if see in this particular next example, there is a huge word, and there are words like this unnecessary words. You say there are T. You need to search the whole length of string to find a letter T, and ultimately figuring out you don't have one. Fine. So that will be the uh, concept over here. So you will end up traversing through the whole string. And what is the string length? Like s dot length can go up to 5 into 10 to the power 4. That's a huge value. So it's a useless waste of memory and time for us. Okay. So how can we improve this? Moreover, can we improve this? So yes, obviously we can improve this, and we have to improve this to do good in like interviews. So what we can do exactly, we can use a memorization. How, say, you can use a hash map or something like that. So what do, you will keep in remembrance that okay, this is uh, the characters we have, and this is their order, and this is a words. Once you come across a word, we should go ahead and check if we have a value like this, and if it has a uh, like it's position is less than this or not. So what exactly we will do? We will first get in, as I said, a hash map. Okay. So in the hash map, say I'm just taking this particular example. Fine. So that will be easier for us to understand. So initially we had B, we had A, C, and D. Fine. And we had A, C, and E. Fine. So that's the point we have. Fine. Now what we will do over here, we will simply uh, add the strings to our hash map. How we'll do that? We won't add the whole thing. We'll add like first task for us will be to add this particular each of the characters of this string, like A, B, whatever characters we have. We should add all these characters that A, that's the characters we should add in our hash map. Okay. So these are the 5 characters given to us, and we're adding this to our hash map. Now what we'll do over here, we'll say we found a first word. We'll not see how many characters are there in the word. We found a word, fine. So we'll do the word dot caret 0. So word dot caret 0 contains uh, A. So we'll use a linked list over here. So I'll show you how we are doing this. But yeah, in the map, we'll use the map to a linked list. So there's the key, and the value will be the linked list, fine. And I find that A is over here, and that's the and or if there are other characters, so that's over here, fine. So we added A, that A is that this is a word that is starting with A, that words 0 dot caret 0 is starting with A, and we just added it in a linked list at A, okay, pointing from A. So that started with A. Any word starting with A are pointed over here. Then you find B, so we add it over B, fine. That's B, and B is pointing. We are not bothered about the other characters of the particular word. So with this first checking that we got a first character, and we're mapping it to that first character only. Then you got ACD. So it's a linked list. So the next word will be A, C, and D. Fine. We're just putting it in a linked list, and we find A being our first character we found. Then you got ACE. Sorry for the improper handwriting, but yeah, this is the ACE. So we again got A, C, and E. Fine. ACE, we found that it starts with A, and we should go ahead with it. Next, in our further steps, we just add it to all the words in our hash map. Now, what we'll do, we will simply go ahead and make a size -1. How? We'll take one by one, like one by one word from this linked list. Fine. We first do A. We'll remove this first character. Okay, and whatever character is left out, we'll remove this first character. So it's a linked list, so you can understand that we can do remove first easily. Okay, and then we'll simply check like if this character, if this particular word length is word length is one, like double equals one. That means it's a single character that's equals to this uh, particular length statement. So we'll just increment counter plus plus. Right. So that's a count plus plus. Now we'll go to the next word. Okay. We'll over here we'll just take like what dot carry type. We don't make a linked list over here. Like we remove this word first. Then we come to the next one. Right? We remove this word first. Then we'll now check that if its length is one. No, its length is not one. Its length is more than one. Fine. Now what we'll do, we'll simply go ahead and we'll do a substring of the rest of the word, right? We did a substring of the rest of the word. Remember, substring is slower. We'll look into if we can find a better solution at last, but let's understand the solution. So we'll do a substring of the word, fine. Now we got CD. So we removed our first character and we do CD. So CD is what? CD is a falls in the string of first character C, and we should find other characters later. Fine. Next, we are going ahead with ACE. So ACE is like we again remove the first character A, and CE is given to us. So we again mark it as C and E. Fine. C and E. Fine. So thus we can see not E. Okay. Just a second. I just drew it to reverse one. C and E is over here. Fine. We just got our characters. Now, what we'll do exactly is like we will see we got a B and B. Next thing is B and B we got, and now we will again check for the characters over here, and we find that once we remove B, the next character is also in B. Okay, so we cannot go ahead in that. Why? Just because once we remove this particular like take this out and remove the first character B, okay, and then we try to like get a word out of it, like try to find a character, but like it's more like we are not going in random fashion. Okay, we are rather going in like once we are in B, it will have a check for like we will go for each of the characters in S dot in S. Fine. So we got A, B, C, D, E. So first we went through all the A, and anything added like if any word was there like A or B, so that will be added over here. Fine. But we won't be looking into A further. You understand that? We won't be looking to A further. So whatever the values of A are there, we got it initially. And if there is a repetition, that will be sitting over here. So by our formula we just defining, so we just removed B, and B is added over here. Fine. That's weird. Next, we'll go to C. Why we are moving ahead? We are not going by all the stuffs that are being newly added and all. We are not going by that. We are rather going by each of the characters over here. Once we traverse each of the characters, we are over with it. Anything being added to previous order, we are not bothered with it. If anything is farther there in the down, that we'll look into it, but not in the previous order. Fine. So that's more or less the idea. Now, BV is not counted. Next, we got C, D. So in CD, C will remove C, and for D, we'll add it to over here. Fine. So that's the D we added. That's the bracket, okay, by side. Then we found CE, remove C, and add E over here. Fine. We'll add E over here. Fine. Next, we come to the next two characters D. We'll remove D and find that this equals 1. So we'll increment our counter. Next, we find there's no more. So we move to E. And if we find E, okay, we'll remove E, find this length is 1, and we remove increment our counter. So our counter becomes 3, and we have traversed all the values only once in the particular sequence. So once we did that, so once we did that, so we can be rest assured that we went through all the values. So that's more or less the whole idea behind this. But also, just to note that we were using substring. So substring is time consuming, but you could use an array as a map to further improve this solution. Okay, so that's definitely possible. We'll look into that if possible. But let's understand this particular concept that how we actually did this. We simply went ahead with each of the characters in our string, like S given to us. In that, we'll simply check for all the words given to us, we kept on checking the first character, okay, and removing the first character. So that was the idea behind this, okay. So it's if you just look ahead, so it's like order of S plus W into L. So W being the number of words and L being the length of each word. So W into L, we are going here and add it to S. That will be S be the length of a string S. So that will be the complexity for this question. Okay. So next I will go ahead and write this code, and then I hope you can understand this particular idea of what we are going ahead with a bit further, a bit better in this way. Okay, fine. So let's go ahead with that. Let's write this code and understand what this code is all about, like how we can actually implement this using our idea, the idea we just thought of. Fine. So as I say, we'll use a map of a character, and we'll use a queue of strings as its value. Okay, so that will be the first thing, and let's try the whole thing, and then I'll explain it again. All right, so here you can see that this is our solution on that which is accepted. This is not the fastest solution. We should think on finding a further faster solution. But let's understand what exactly we need to go along with our particular solution. Okay. So the first thing is we just took a map of characters and a queue, the one I was just showing you. And then in that, we just added all the characters in S, that being each of the key in our map, and with as a value added new linked list. Fine. And for each of the words we found them across the words array, we simply check the word caret 0, and we check if the key is there already. Okay, if the key is already there in our map, we'll add that. Or if the key is not there, say in the case of the second example, there isn't any T starting with T, right? So the caret 0 is not there in our initial string. So there's no point going ahead with this. This is already not in our possible solutions of the possible count cases. Fine. So we should just ignore that. Further, what we'll do, we'll simply like we added those words already this, and now we're going for each of the characters in the is. So if there are like two times a being there, so that case a being repeated, like A and A, you can see A being repeated, so we can come across those solutions. So that's the stuff we're going ahead with. Okay, so and that was the case BB. So this B was not repeated any further, so that's the reason we didn't come across the second B anytime, and that was not counted in our solution ever. So that's the idea. Now we took a queue, and in the queue we just take whatever the current value of our current character we have. Whatever the current value we have, we just take it, fine, and we just take a size of it. Now for 0 till the size, we go through all the current elements in our queue, and what we just do q dot poll. That is, we take out one of the like each of the elements from our queue. Okay. Now a q dot poll is actually FIFO, like first in first out. So whatever element is inserted first comes out first. So there's no need for queue poll first poll. So like it's simply a queue, not a DQ. Okay. So we took the string or the first string we got. Now in the string length is 1, we simply incremented our answer. Answer being the final return answer we got. That is the counter. And then if it's not 1, because there are more characters, so we check if a map contains a key of character 1. Okay. Say there's an word like this. Fine. Word like this. No, not this exactly. Um, H, P. Okay, fine. So you look at this example. Fine. After A and H got inserted, then what will happen? We come across a character that B. Fine. So B, we check if B is a key in our string or not. If it's not a string, we'll simply ignore this. Fine, we will not add it if it's not a string. So if it has characters there as a key to our map, so we just add our character like cat a string the caret I, and we add it to like we do a substring over it. So this is the one that takes the most of the time. So if you want to improve the solution, you need to improve this at this position, because this improves our time complexity. You can go ahead with using some kind of string buffer or string builder kind of stuff, and also you can do like the initial one I was talking about, like you can use an array as a map to further improve this solution. So that can be possible to improve this kind of solution. Next, we simply what we did, we simply added the rather part. We just removed our first character and added rest of the characters with a particular value we got. Okay, so that's the idea. That's the whole idea behind this question, and that's how we solve this question. And as I said, if you want to improve this solution, you need to improve it on the substring part. Also, if you have any further better solution which you think can like a better, not solution, rather a better thought process, a better approach to this question, I would love to hear to that. Make sure you write that in the comments below. So that's more or less about today's video. I hope I can make you understand what how we can solve a question like this, or what should be a thought process behind solving a question like this. uh, Make sure to subscribe to our channel for regular LeetCode videos like this. Also, like this video and comment down any of your thoughts or any of your doubts related to this question. I'll be happy to help you out in the comments as well. So thank you all for watching this video. Hope to see you soon in my next video as well. Thank you.